Today we're looking at rhombuses, rectangles, and squares through the lens of a coordinate proof. And we have a few examples to go through here as well. Let me first take you back to the previous chapter and show you this Venn diagram that we made. Remember when we were studying the properties of parallelograms, we said a rectangle is a special kind of parallelogram. It has all the properties like opposite sides are parallel, and also you have 4 right angles. We even said a rhombus is a special kind of parallelogram. Again, opposite sides are parallel, and here you have 4 congruent sides. And that square was the blend of the two, where it had all of the properties of the rectangle and all of the properties of the rhombus. So just keep that in mind. We're summarizing those things here just for your reference. You can see it says that a quadrilateral is a rectangle if it has 4 right angles. Now remember, we know a square also has 4 right angles, right? So that's because a square is a special kind of rectangle. So what that means is as we are trying to classify shapes, we have to look at more than just the right angles, because we know 4 right angles show up in now 2 shapes, both the rectangle and the square. And so in order to make a distinction between those 2 shapes when we're classifying our shapes in our coordinate proof, we will also have to look at the sides to see if we have 4 congruent sides or if we don't have 4 congruent sides. So we're calculating more than just the slopes to determine if we have right angles. We're also going to be looking at the sides. Similarly, if you are classifying a shape and you get 4 congruent sides, you know that's going to show up in both the rhombus and the square. So we have to do more than just calculate the length of the sides. We also need to look at the slopes to determine if we have right angles or not, because if there are no right angles, it's got to be a rhombus, and if there are right angles, then it's a square. So we really have to separate these out. Now, the way these examples are provided is they're starting you off with a specific shape. Here we're starting you off with just a rectangle, and we're starting by looking at just the properties of a rectangle through a coordinate proof. Like we're going to determine that it just has 4 right angles, and that's just one component of it, and look at the diagonals and so forth. So we're looking at specific properties of the rectangle and the other shapes today, but starting in the next lesson tomorrow, that's where we open it up more and we just say classify the shape, meaning you got to figure out what it is. So we're really reminding you of some of these key properties. As we move forward, we can either focus on the 4 sides or we can focus on the 2 diagonals. It's a little bit faster if you focus on the diagonals, and I'll do some future examples with that, but not today unless it's specifically asking us to work with diagonals. But in the future, if you're trying to classify the shape, you can focus on the sides or the diagonals. And just again, a reminder that if you are going back and looking at the previous chapter of notes, we had a flow chart here where we were looking specifically at the diagonals and the properties in each of those shapes. And that's a nice little reference so that you can remember what the diagonals are doing or not doing in each of those shapes here to help us distinguish between the rectangle, the rhombus, and the square. But like I said, today it's just let's start with the rectangle, let's look at a few properties, then look at the rhombus, look at a few properties, and so forth. So you remember, of course, that the rectangle has 4 right angles. If you think about what that means, we know right angles are formed by perpendicular lines, right? And perpendicular lines have slopes that are opposite reciprocals. In other words, you are using your slope formula. Now we had this also on the previous page of notes just as a quick reminder. If the proof is asking you to show that adjacent sides are perpendicular, or if you have 4 right angles, again, 4 right angles are created by perpendicular sides. That means perpendicular sides must have slopes that are opposite reciprocal. So that's how you know we're using the slope formula. So that's a reference for you again, just a reminder there. And if they're asking about if anything is congruent, whether sides are congruent or diagonals are congruent, remember congruency is talking about length. That means you want distance formula. So let's start with our example down here. This is example number 1. We're going to write a coordinate proof for some of these properties that we see here in the rectangle. And let's call this a bottom of length A and a height of length B. So that means point Z is located at A, comma 0, and point X is located at 0, comma B, and point Y is A to the right, B up, so A, comma B. So we have these variable coordinates. Remember, if we prove it with variable coordinates, then it's guaranteed to be true for numbers of any shape and size. So we're going to start off with, does this have 4 right angles? Now, again, we know the answer is yes. So the proof should align to our expectations. So let's start off with our slope. And I'm going to start off with the top side. This is segment XY. Our slope formula is y's over x's, so the y coordinates are the b's, so b minus b, and x coordinates are a and 0, so a minus 0, and you get 0 over a, and 0 divided by anything is 0. And that should make sense because that's the slope of a horizontal line. It should be horizontal if it's parallel to the x-axis. So then right underneath that, this is the slope from W to Z. We have 0 minus 0 over a minus 0. That gives us 0 over a. And yeah, those are parallel because we got the same slope. Top is parallel to the bottom. Now let's do the left and the right sides. Slope of xw on the left. Y coordinates b minus 0, and the x coordinates are 0 minus 0. Now anytime you're dividing by 0, we call that undefined. In other words, it's a vertical line, which makes sense because it's on the y-axis. On the right-hand side, slope of yz, b minus 0 over a minus a. B over 0, once again, undefined. So if you take a look at these two, again, those are parallel because you got the same slope. But what we're trying to figure out is if you have right angles. And normally, if you have perpendicular lines, you're looking at those adjacent sides to see if those slopes show the pattern of opposite reciprocals, meaning you change the sign and you flip the fraction. And that doesn't work here because undefined is not a number that you can change the sign or flip a fraction for. So you have to remember your special case for vertical lines and horizontal lines. A vertical line has undefined slope. That's what we have here. Its equation uses x. And the horizontal line has 0 slope, and its equation uses y. So recall that vertical lines are always perpendicular to horizontal lines. So normally we're looking for slopes that are opposite reciprocals, but in a case like this, these are special cases because these are vertical and horizontal lines. We just have to remember that vertical lines are always perpendicular to horizontal lines instead. So that means these are perpendicular, therefore they form right angles. And these are perpendicular, and they form right angles. These are also adjacent. These are perpendicular, they form right angles, and these are also adjacent, and again, they're perpendicular. So we always finish off with a conclusion, and we'll say WXYZ is a rectangle because it has 4 right angles. Now we already know it is a rectangle, and that really wasn't the question. It wasn't saying prove that it's a rectangle, but the reason I'm using this wording is really for tomorrow and the days that follow it, where it's more open-ended, and we're saying you figure out what shape it is. You always declare the shape, and then you explain how you know by interpreting your results. Let's show that a rectangle has congruent diagonals. Again, that's a property. We see that here. Congruency means distance formula, so let's find that. So if I were to draw a diagonal from W to Y, that's the diagonal, we want to know what the length is. So x coordinates, a and 0, you subtract them, square the result. Y coordinates are b and 0, subtract them, square the result. You have the square root of a squared plus b squared. Again, this does not simplify because of the plus sign. Only if you have multiplication can you simplify individual factors. These are not factors. Now for x, z. It's almost looking the same, but we will get the same results. a squared plus b squared under the radical. So our conclusion is wxyz is a rectangle because its diagonals are congruent. Now, before we go any farther, we know this is a rectangle, but if we're only looking at the feature of it having 4 right angles, remember too that 4 right angles show up in both the rectangle and the square. So how do we know if this is a square or not? All right. So if we were to take a step farther and ask that question, how do you really know it's a rectangle? We have to eliminate the possibility of it being a square. So right over here, I'm going to compare 2 adjacent sides. Now they don't look congruent, but again, we don't go by looks. We need to prove it. So how far is it from x to w? All right, so from x to w, we could use the distance formula, of course, but because it's a vertical line, you're allowed to. Now, if we have grids, we count, but here what we're doing is we're subtracting the height, so the y-coordinate minus the y-coordinate. So the reason for the absolute values is because we want it to be positive. Now, we know it's b because we labeled it as such, but that just proves that it is b. And now if we compare an adjacent side, xy, again, we know the distance is a because we labeled it, but if you were to do a subtraction problem with your x-coordinates, you get a. In other words, if your adjacent sides were the same, if they were congruent, you would have a square. But because adjacent sides are not the same, it cannot be a square. So that's how we know it's a rectangle. We'll be adding that layer of detail in future notes. All right, quick question of, is a rectangle a parallelogram? Yes, you just have to look at the slopes, right? We don't have to calculate it all over again because we already did that. Look at your adjacent sides, these are your adjacent sides. These are your opposite sides, and the opposite sides have the same slope, so they are parallel. So that's one pair of opposite sides parallel, and here is a second pair of opposite sides parallel. So we can jump right to our conclusion. WXYZ is a parallelogram. Now we know it's a rectangle, it's a more specific shape, but it is a special kind of parallelogram. So you think about the definition of a parallelogram, say because both pairs of opposite sides are parallel. And with that, there we had a couple of examples on the rectangle. So let's take a look at our next shape. It should be our rhombus. And again, just a quick reminder, here are a couple of key properties. We have the 4 congruent sides, right? Remember, congruency means length, so that would be our distance formula. And you could also focus on the diagonals. Here the diagonals, they're not the same length, but they will be perpendicular, and perpendicular lines will have slopes that are opposite reciprocal. So again, slope formula here. Again, we see these we see these qualities in other shapes like the square. So if we had to classify the shape, we would also have to examine these angles to see if they are if they're right angles or not, if we have perpendicular sides. But that's a little bit beyond what we're just using these examples for. So here's example 2. We're going to write a coordinate proof, and we're just showing that it has 4 congruent sides. We're keeping it straightforward here. Now, here's a horizontal side at the top. We know it's horizontal because the y-coordinates are the same, so we can calculate that length by subtracting the x-coordinates. We just have to show it, right? So again, we use that absolute value just to make sure that our distance is positive, and the absolute value of -5 is +5. The bottom, we're going from 0 to 5, so yeah, that's also going to be 5, but let me just record it. WZ equals, so 5 minus 0 is 5. So there's 2 sides. Now we have to figure out the left and the right side. Those are slanted, so that means we have to bring in our distance formula. So on the left side, we're talking about WX. 3 minus 0 quantity squared plus 4 minus 0 quantity squared. That will give us 9 plus 16. which is root 25, and that's exactly 5. But we have to find the fourth one as well. YZ is the square root of 8 minus 5 quantity squared plus 4 minus 0 quantity squared. So we get a 3 squared and a 4 squared, and we see the same pattern as before. That's 9 and 16, which is a root 25, which is a 5. So yeah, we do have 4 congruent sides. Conclusion, WXYZ is a rhombus because it has 4 congruent sides. And finally, we get to the square, which is really a blend of both the rectangle and the rhombus. Here in this second line here, this is what we're more used to. We're looking at the sides and the angles. It has 4 right angles, 4 congruent sides. Again, right angles, you find that with your slope formula. 4 congruent sides, you find that with your distance formula. But you could also focus on the diagonals. You would have to show that the diagonals are perpendicular. Again, that's your slope formula. And that the diagonals are congruent, and that's your distance. So you're using the same formulas. It's just that here you are working with 4 sides, and here you have only 2 diagonals. So that's actually a bit faster and more efficient. But for this example, here we have a square. Let's take a look at a few of these properties. So in choosing the side, I'm using letter A to represent that side. And of course, if it has 4 congruent sides, we're labeling it with A. And so our coordinates are going to be A, 0 at point Z, point X is 0, A, and then A, A. So let's show that it has 4 right angles and 4 congruent sides. So 4 right angles, that means we want to show adjacent sides have slopes that are perpendicular. So slope formula, in other words. So the top side, the slope of xy, a minus a over a minus 0 is 0 over a, and it should be 0 because that is a horizontal line. On the bottom side, wz, 0 minus 0 over a minus 0 gives us 0 over a. Once again, we have a slope of 0. So yeah, those are parallel. And then for the left side and the right side, they look vertical, but we have to calculate it. So xw on the left, a minus 0 over 0 minus 0, you have a divided by 0, and that's of course undefined. And then on the right hand side, slope of yz, a minus 0 over a minus a. Once again, we're dividing by 0, we get undefined. So we saw this pattern earlier with the rectangle. Opposite sides are parallel. Adjacent sides have slopes. Well, we can't look at the opposite reciprocal. We have to memorize that horizontal lines with slope 0 and vertical lines with undefined slope are perpendicular to each other. So yes, we do know that we have 4 right angles. Before we write the conclusion, we also want to show that it has 4 congruent sides. And because this is horizontal, we could use the distance formula, or we could just do a subtraction problem, and that's what I'm going to do here. So from x to y on the top, subtract those x coordinates, so a minus 0. On the bottom, w to z, subtract those x coordinates. On the left-hand side, xw. Now this is the heights. We're subtracting the y coordinates, so a and 0. And yz on the right. Again, the height, so you want to subtract the y coordinates. And you get the exact same length. So our conclusion is wxyz is a square because and now you list what it has. It has 4 right angles. We know that because our adjacent sides are perpendicular. So we say it has 4 right angles and 4 congruent sides. So these last 2 parts, just to kind of finish up with a couple other questions. questions that might come up. What if we're talking about the diagonals? Now notice here, we're not looking at the full property of both perpendicular and congruent diagonals. They're just picking this one only. So let's take a look at the diagonal from W to Y and calculate its length. All right, so we have a minus 0 quantity squared plus another a minus 0 quantity squared. And so what that means is you have a squared plus a squared, which is 2a squared under the radical. Now the 2 is not a perfect square, but the a squared is. So what that means is you can simplify that into, so root 2 times root a squared, and that will simplify into a root 2 times a. There's your variable in the back, and there's the coefficient in front. So then the other diagonal from x to z, we have, for x coordinates, a take away 0 quantity squared, and then 0 take away a quantity squared. So we will get the same pattern here. And there's the result. So notice we get the exact same answer. So yes, those diagonals are congruent. So our conclusion is I'll write it this way. I'll say the square has congruent diagonals. And then, is a square a parallelogram? Yes, it is. We would look at the slopes, and we already calculated that, so we don't have to do that again. You can see both pairs of opposite sides are parallel. So to finish that up, I'll squeeze that over here in the margin. And I'll write WXYZ is a parallelogram. Same as what we saw before, because both pairs of opposite sides are parallel.